Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Contest alert. This week we have a jam-packed intro, including a new contest we're launching, so please bear with me. You don't want to miss this one. First, a bit about this week's shows. As you may know, I spent a few days at CES earlier this month. While there, I spoke with a bunch of folks applying AI in the consumer electronics industry, and I'm including you in those conversations via this series of shows. Stay tuned as we explore some of the very cool ways that machine learning and AI are being used to enhance our everyday lives. This includes work being done at Anki, who built Cosmo, the cutest little computer vision powered robot. Lighthouse, whose smart home security camera combines 3D sensing with deep learning and NLP. Intel, who's using the single-shot multi-box image detection algorithm to personalize video feeds for the Ferrari Challenge North America. FirstBeat, a company whose machine learning algorithms analyze your heartbeat data to provide personalized insights into stress, exercise, and sleep patterns. Reality.ai and Koito, who have partnered to bring machine learning-based adaptive driving beams or automatically adjusting high beams to the US. And last but not least, Aerial.ai, who applies sophisticated analytics to Wi-Fi signals to enable some really interesting home automation and healthcare applications. Now, as if 6 amazing interviews wasn't enough, a few of these companies have been so kind as to provide us with products for you, the TWiML community. In keeping with the theme of this series, our contest will be a little different this time. To enter, we want to hear from you about the role AI is playing in your home and personal life and where you see it going. Just head on over to twimlai.com/myAIcontest, fire up your webcam or smartphone camera, and tell us your story in 2 minutes or less. We'll post the videos to YouTube, and the video with the most likes wins their choice of great prizes, including an Anki Cosmo, a Lighthouse smart home camera, and more. Submissions will be taken until February 11th, and voting will remain open until February 18th. Good luck. Before we dive into today's show, I'd like to thank our friends at Intel AI for their continued support of this podcast. Intel was extremely active at this year's CES, with a bunch of AI, autonomous driving, and VR-related announcements. One of the more interesting partnerships they announced was a collaboration with the Ferrari Challenge North America race series. Along with the folks at Ferrari Challenge, Intel AI aspires to make the race viewing experience more personalized by using deep computer vision to detect and monitor individual race cars via camera feeds and allow viewers to choose the specific car's feeds that they'd like to watch. Look for my conversation with Intel's Andy Keller and Emil Chindicki earlier in this series for an in-depth discussion about this project. And be sure to visit ai.intel.com where you'll find Andy's technical blog post on the topic. Now about today's show. In this episode, I'm joined by Michel Allegue and Negar Ghourchian of Aerial.ai. Aerial is doing some really interesting things in the home automation space by using Wi-Fi signal statistics to identify and understand what's happening in our homes and office environments. Michel, the CTO, describes some of the capabilities of their platform, including its ability to detect not only people and pets within the home, but surprising characteristics like breathing rates and patterns. He also gives us a look into their data collection process, including the types of data needed, how they obtain it, and how it's parsed. Negar, a senior data scientist with Aerial, describes the types of models they use, including semi-supervised, unsupervised, and signal processing-based models, and how they've scaled their platform, and provides us with some real-world use cases. And now, on to the show. All right, everyone. I am on the line with Michel Allegue and Negar Ghourchian. Michel is CTO of Aerial.ai, and Negar is a senior data scientist there. Michel and Negar, welcome to This Week in Machine Learning and AI.
Thank you very much, Sam. Very glad to be here with you.
Thank you very much for having us.
Absolutely. Why don't we get started by having you tell us a little bit about your backgrounds? Michel, why don't you get us started?
Perfect. Thank you very much, Sam. My background is in the digital signal processing and telecommunications. I earned master degrees and PhD degrees in Spain, in Seville. And then I moved towards to work with the University College Dublin in Ireland and the European Space Agency before becoming a permanent resident in Canada, which we started Aerial in Montreal in 2015.
Awesome. And Negar, how about you?
So I started my studies in electrical engineering, and then I moved slightly from my master towards speech processing, telecommunication, speech recognition. And that's the first point I got introduced to machine learning field. And I liked it. I liked working with data and human-centric data specifically. That's where I decided to start my PhD at McGill University at Montreal. In computer science, more towards machine learning applications and mining human-centric data. And then right after that, I joined Aerial as a data scientist.
Awesome. Why don't you give us a little bit of an overview of what Aerial is up to? It seems like a really interesting application.
Yes. Well, Aerial basically reuse Wi-Fi signals to understand a little bit of context about the environment. So you have Wi-Fi signals bouncing all over the places indoors, basically. And then we reuse statistics from the Wi-Fi signal to understand the environment, such as human presence, pets presence, for example, to be applied to home automation and healthcare applications, basically.
Yeah, I think I've told this story once on the podcast before. A few years ago, I was interested in doing a project around home automation, and at the time, this was before really computer vision with deep learning, had the advancements, the recent advancements. And,
yes.
I pretty much got stuck out of the gate trying to figure out a cost effective way to do presence detection. There were a bunch of different ways to do it, but, we were talking about things like trying to put NFC receivers by doors and stuff like that. And it was really messy. And now there's a bunch of interesting ways to do it, including just put cameras by doors and do object detection. But what you're offering seems to be a really interesting way to just piggyback of stuff that's already there.
Exactly. That's our main purposes, Sam. To reuse those wireless signals that when no one is at home, they behave in a very particular way. When someone just show up, they behave completely different. And that's when our work starts, by identifying those patterns.
Can you tell us a little bit about the science behind it and what makes it work? I'm imagining, it just has to do with kind of the density and water content of our bodies, and they change the radio waves bounce around, but I'm sure there's a lot more detail to it there.
Yes, it's a pleasure too. So actually, Wi-Fi signals and Wi-Fi is a pretty smart system, and it's all the time sensing the environment. And that's exactly what we use. We use any statistic from physical layer up to link layer. And by looking at these statistics, you're basically sensing the environment with any two Wi-Fi devices that are connected each other. Let's say your router and your TV. We are already sensing in that scenario. Basically, your body, while your body moves through those signals, your body disturbs those signals in a very particular way, depending on what you're doing, how fast you're going, and what are the activities you are involved in, basically. Machine learning and AI comes to we start with the pattern recognition, but it's more complex than that. And it's actually machine learning and AI is the answer to our research questions, and is providing us with very good results. That's what we are using machine learning and AI today.
So maybe Negar, can you tell us a little bit about the pipelines that you use and the types of data that you're collecting, how you're collecting it, and how you're turning that into models?
Yeah, sure. So what we do is that technically we use like Wi-Fi enabled devices in indoor spaces to scan and record these Wi-Fi statistics that Michel mentioned. So technically, we are turning the routers and Wi-Fi enabled devices to some cameras, let's say the hidden cameras, to scan the environment where this Wi-Fi signal propagates. And then any event and motion that happens within an indoor space affects that statistics. And that's where we, through the routers of each household, we scan these statistics, we send it to the cloud, and that's where we start processing the data from.
How granular can you get with the data off of the Wi-Fi routers? Is it able to uniquely identify individuals within a home, or just that, maybe that there's someone there, or you mentioned pets. How much detail can you get out of these signals?
Yes, it's a very fine-grained data, Sam. And we, as you mentioned before, we are able to identify different users by the body mass and the way they move on the space.
Okay.
And these signals could be as sensitive as that we are able to detect a breathing rate, for example. In the right positionings, by the action of breathing, you're moving your chest, and that's modulating our signals as well. And we are capable of detecting a breathing rate, for example. It could be as granular as that.
That is incredible. I find that really difficult to wrap my head around. Is this all done without requiring me to change the access points I'm using, or do I need to use specialized devices?
You don't need to use any specialized devices. It's Wi-Fi devices, and we look at statistics within the Wi-Fi standards.
Do you require like some of the newer Wi-Fi mesh networking technologies, or I've got one standard kind of old Wi-Fi router, and are you also looking at? Do you also get statistics reported from the client devices, or is it just the access point?
It could be from both sides, actually, or one of the sides involved. It could be one client, for example, and we collect data in the client and send it up to the cloud, or we could be on the router looking at multiple clients at the same time, and we upload the information. And regarding so as long as you have N devices in your home, IEEE 802.11n and above,
okay,
we're good to go.
There's a new one coming out soon. I just read about. Is it X?
Yes, there are new standards coming up. All of them are improving actually, and are providing even more fine-grained data to us. Actually, the best, the better that Wi-Fi gets, the best for us. Mesh is also a very interesting topology for us to be in, and we are very excited to work in Mesh as well.
So I've got my Wi-Fi network and my access point, various clients. How do you collect data? Is there like a mobile client or something like that? Or is it another device type that you're introducing?
Basically, if we can upgrade the firmware in your router, That would be the ideal point to be in, as we're gonna be deploying the system very soon in with one of our ISPs. That's the way we're gonna use. So we just need to update your router, for example, your ISP's router. We could also be in one dump client that we could provide you with, and our agent, the agent that collects the data and send it to the cloud, is in these small devices that we could provide as well. But as long as we can update any firmware of any of your devices, we are ready to go from there on.
Okay, so is the implication then that the business model, at least as you envision it today, is less direct to consumer and more either via an OEM with a router or via an ISP relationship or something like that, where they can change the firmware for you?
Exactly, yes. We're going through ISPs initially. That way we feel as well that we could get to a big market. But of course, the users is the same, right? Either you go directly consumer or through ISPs. At the end, you have the same users. At the end, you want to provide a very cheap security system, for example, to your customers, where you're going through an ISP or you're going directly. We have chosen the ISP because it's a very good business model. It's very clever. And that's the way we're going to start.
So you're collecting this data. Can you be more specific about the types of data that you require, the specific types of values?
Yes. For example, we collect every data available at physical layer, for example, and we upload that. Let's say RSSI values. Let's say commutings on the rate on your device. Let's say channel information. We collect all this type of data, and all of them are very sensitive to what's happening in the environment. And we work from there. We start summarizing, we start doing feature extraction on top of that, until we reach to our processing engine with the models and all that.
Okay. So you've got all this data. It's uploaded to the cloud. Negar, how do you even start to build models around this? For example, are these supervised models? And how are you training against this type of data?
Yeah, it's a very tricky and interesting, actually, question. So we received these variety types and a huge amount of data from each house. And then depending on the task we have in hand, we decide to choose an algorithm or a learning method that actually minimizes the requirement for query the user very often. So we try to go with the setups that we don't really need to get through labels from the actual users, but we try to kind of in unsupervised setup or semi-supervised learning setups that we get a minimum amount of information from the environment, from the user per se. And then the rest of it's on us to actually predict models, build models. In some applications, we could go fully unsupervised, like the security application. But as more complicated tasks comes in, like activity recognition or healthcare applications, that's where actually we will need the minimum amount of label provided by the users, or we could have extract these through labels automatically from the rest of the feature space we extract, and use them as reference point. And over time, as a user use their application more and more, we correct our models technically based on the first initial models that we built.
Can you give me an example of how you're able to automatically extract labels from the data set?
Yeah. For example, we have some specific features that we extract from the routers directly. Gives us a rough estimation, or even like sometimes a very good estimation of a location of a user with respect to the fixed anchors that you have at home, right? So that will roughly give you an estimation of the location of a person, and then using the time of the day and the pattern of move as part of the amount of motion that each person has 24/7, that can kind of roughly give you a good idea of that, like how was that user moving and behaving throughout the day.
Okay, so I'm imagining things like you can figure out how many of the devices, how many of the clients are cell phones, and that gives you a sense of the number of people that are in the home. And then you can, like at night, the cell phones are probably not moving and you kind of know where they are in the home, and you can start to build some labels from there. Is that the general idea?
That is like something that we definitely think about, and we can, but we're not limited to those type of getting. Yeah, we can use those information about different users getting connected to a router. We have access to that when we sit in a router. We have access to those kind of information, but necessarily is not the only source of information we extract. But definitely the goal is what you mentioned, to actually learn the pattern of like the behavior of each individual user that lives in a household over time. You know, we start off with some general models and general assumptions about how people live in a house, how they move, where they go, when they leave home, when they come back. And then these general assumptions will get edited over time with different models that we have. And the models get updated, particularly for each house.
So I kind of get that in the general case of kind of presence detection. But when we're talking about the breathing example that Michel mentioned, which you also mentioned healthcare use cases. I'm assuming that is related to a healthcare use case. How do you begin to build a model around that?
You mean about breathing rate?
Right.
Yeah. So in those cases, most of the techniques that we would use is like signal processing and like more of time series analysis, finding seasonality, finding the periodicity in the signal. That's more of those type of techniques we would use to actually find the pattern. Because the breathing rate is something cyclic, and then it's something that you could actually detect information. With regard to presence detection that you mentioned, no matter like presence detection could be like for us, it has different definition. When you have movements or like very intense movements, that's easier to figure out. But also when you sit somewhere or where you're trying to stay steady, or when you're asleep, that presence detection in that level is just, we are looking into finer grade like motion and activities that it just presence of a body would have on the data, and then figure out that there is someone there, and then someone is breathing or someone having very micro movements, versus when a house is empty.
Right. So in other words, the presence, when you even think about the notion of presence, you're trying to pull out a rich set of parameters, localization of the people in the house, things like that. It's not just empty or a person in the house.
No, that's improving with the different applications we're developing.
Right. And so when you have applications that require some type of labeling, it sounds like maybe you're doing that via direct input via mobile device or something?
In some cases, yes, we could get the direct entries from a query user that to give feedback or label on some particular activity or some particular state of a house, for example.
But the idea, just to complement a little bit on that, but the idea is to actually minimize the query to the user. For example, in applications such as elderly care, healthcare, and in particular elderly care, we don't see the user interacting too much with our system.
Right.
So we are auto-generating our labels to fit the different type of models we use. But of course, you cannot expect too many labels or be interacting too much for this particular application. It's not difficult to figure out, for example, where how people walking in the bathroom looks like, how people walking in the bathroom looks like, how brushing teeth looks like, is because you could correlate with the time of the day when they take the actions from the moment they start walking in the morning or at any time.
Wow. How does the system scale in the sense of the number of individuals per access point? I guess I'm wondering I guess I'm wondering if you have multiple people, like if you go from a house environment to an office environment or something like that, do you start to lose your ability to get fine-grained information about what's happening within the environment, or is it your visibility proportional to the number of access points, and as you increase people, you increase access points, and you're still good? Like, what are the issues there?
Yes, exactly. Definitely, the fewer number of people that you have in the sensing area, the better. So let's define a sensing area such as your access point and one client connected to it. So you're sensing one specific area because these two devices are fixed. Let's say the more granularity you want with more people around, you will need to increase the number of independent sensing areas. That will give you enough resolution to keep working. But of course, if we are talking about, if we move from residential applications towards more commercial or business settings, you will lose resolution. It's not the same of to track 5-6 people versus 50 to 100 people.
Right.
It's very interesting. Actually, we are doing it today. We have deployments in large offices, and the patterns are very, very interesting over day, over night, over weekends, over holidays. It's very, very interesting. But of course, you lose a little bit of resolution in terms of who's walking there within 100 users, right?
Yeah, you mentioned the sensing area is an access point and a client connection. It's got to help you that pretty much everyone is walking around with a client nowadays. And so each incremental person, does that create its own sensing area if they've got a mobile device?
Yes, for sure. And that device is moving. And we can use it. We are doing it, and we are planning to rely on devices as well. But let's say the beauty of our technology, and when we are spending more time, is in those scenarios where you are not carrying your mobile with you.
Okay.
And if you think about it, one of the first things that probably you do when you get home is to get rid of your cell phone for a little bit. and we don't want to lose that type of information. No, you're walking, you want to arrive home, you want to probably relax. So we want to know that. We want to know that to give you the right tone for your lights. We want to turn on your TV, for example, on your favorite channel. And we want to prepare the scenario for you, even if you're not wearing a mobile. We don't see you controlling the home with your mobile all the time next to you, following you everywhere.
This is a really fascinating application. When can we, as consumers, expect to see this more broadly available?
Well, this year we are deploying with one of the largest ISPs in the world. Unfortunately, I cannot reveal the name yet, but it's huge. We'll be with them in a peace of mind application for families to know where there are people at home or not, who has arrived home, and prepare. A kind of home automation type of applications. as well as we are also working very hard for our elderly care applications, because the market is huge as well there. And we are very fascinated about the elderly care applications. We can provide so much information to the caregivers and even to the doctors of those patients they don't have it today. There is no way without the camera that you can tell how many times a person is going to the bathroom, how much time is spending on the bathroom versus taking a shower. So the pressure is so high because we can do it. That we would love to go to that market right away. We would love to extend elderly population time at home as much as we can. And even after being discharged for the hospital, let's say for something, we would like to track to see that everything is going well at home.
And is the resolution fine enough such that you can detect like fall events and things like that?
Yes, actually, that is one of the most interesting applications that we started off and many people are asking for. So fall detection is one of the major actually goals that we're setting for our elderly care application. And because it's happening in a part, usually mostly it's happening in some shower areas, math areas. We have very hope to get it and sooner when we start working more focusedly on our elderly care application.
And what do you expect the approach to be to detect falls based on this data? Is it kind of a supervised, finding a bunch of labeled falls and training against them? How do you get to that?
Yeah, well, we will definitely starting off with making a lot of fake falls in the office, probably to get a grasp of how does this would look like. But more seriously, we're following to actually go and work with elder care facilities, that they are taking care of a lot of people and patients that live in those centers, and actually fall is something that's very, very often happens there. Okay. And they have already started a lot of studies. They're getting a lot of data about falling. How does it happen? When does it happen? Probabilities around that particular accident, which is very, very common in the population. And then when we learn enough about the patterns and the stuff that we are trying, the features and all the statistics that we're looking for to distinguish a fall, we will go more towards, when we want to apply this, we definitely are going to be applying some anomaly detection algorithms, some abnormal detection, predictive analytics based on the pattern of the patient's or the elderly person's movement during the day or during past days. Because there's a lot of medical studies about that. All of these falls, they don't usually happen unannounced too much. It's not random. There's a lot of symptoms that happens before that, which is alerting. And then we're going to be using all of those information. We're going to get people, experts in those areas to help us to actually build up this model. But regarding the learning procedure, we're going to start off definitely with some supervised learning algorithm to build up models. We're going to definitely use some active learning and other semi-supervised learning techniques to improve that based on the semantic information we will get from the experts in this area. And then, we use the pattern of normal versus abnormal on this particular random things that happens. Then we'll be off without involving user. We'll be able to actually predict at first, to try to avoid and warn healthcare caregivers that this particular patient, with the pattern that he walked, with the pattern of the amount of activity level that it has, it's very probable that's going to have a fall in a couple of few days, or if it happens, we will know and we'll inform the caregivers.
Interesting. How are you approaching the general issue of privacy in deploying systems like this?
Yes, it's a very interesting question. And first of all, we anonymize our data. That's the first step. When Negar and I start looking at data, those are not names already. So those are numbers, tokens. So that's the first step we take. We anonymize the data. You have to understand that before our processing engines arrive, all the data that is there, no one can understand that data. So it's meaningless. It's just raw data going up to the cloud, even though it's encrypted. All the links between our agents and the cloud itself, from cloud to agents, to go to actuators, all is encrypted. Or in the cloud for us are tokens. It's basically anonymized data that we work with. It's just only at the end when we present the results to the user that this data makes sense. And it's only there when that path is encrypted, and it's only when you present data to the user when you assemble again the entire the whole set of information, let's say.
Do you or the company have any philosophical perspective on the issue of privacy as it applies to this kind of technology, which I think really brings a level of transparency to presence and activity in the home that most people probably aren't used to?
Exactly, and you just have to look at our applications, right? The type of data we're going to collect, the only goal is to detect, to be very good at detecting with really high values of true positive and very low false positive values. Try to really accurately detect the events that we are interested for, only the purpose of our final presentation to the user. As you can see in a security system, we're just telling the users, someone is at home,
right?
And it's not normal. This time of the day, since the history we have from you, this is not normal. For elderly care, it's true, we will be looking at the very fine-grained activities, but the entire goal, the outcome of all of that will be, this patient had a normal day today, so everything seems normal, don't worry. Versus, or something has happened, or this is not a normal day for this patient, or a fall has happened. So those type of outputs are the ones that we'll be providing, and we will use the data only to provide very accurate outputs.
Yeah, I mean, it strikes me that we talk a lot about the smart home, but generally speaking, that really is devices in the home getting smarter. But this, offers the possibility of having, the home itself via the wireless network really start to know a lot about what's happening inside of it. And that could potentially create a lot of opportunities for the devices themselves to then take advantage of this and do more interesting things. So it's really interesting, and I appreciate you taking the time to share with us a little bit about what you're up to.
Thanks to you. It's been honestly with this type of technologies when actually we are unlocking the IoT market, because at the beginning there was like a chicken and egg problem. So I have to put devices inside my home, but for what purposes? So what will be the application? And so this type of technology are unlocking because you already have the sensing system there. So let's start using it. That's our main purpose.
Yeah, no, it's really interesting. In fact, I'm so close. I picked it up in my hand now. I recently started playing around with home automation and smart home stuff, and I have this little Sylvania presence detector thing that's hooked up to the Samsung SmartThings hub, and it generally works. It's a little flaky, but in order to really automate the home, you have to put these things all over. And you're telling me that I already have what I need. I just need to start collecting some data and train some models. which of course it makes it sound really easy when you say it like that, but, or wait for Aerial to, show up in my router at some point.
Thank you very much.
Yeah, and then one more thing I would like to add is that we have to look at, when we talk about the philosophy of the company, you could just look back at alternatives that we have right away for doing the same things that we're trying to do. So in order to monitor an elderly person, you would need to make them a wearable, which is very annoying for them, and it needs a lot of cooperation for the person. And or other alternative is using cameras for security, which is voiding the privacy way more than our data would ever could, right? Because camera data, images and videos or microphones that right now is being used for security, for home security and smart homes, they're way more the transparent data that anyone could pick up, look at them and see what's going on in your life. Whereas like our data is something that's need a huge amount of processing, which you need to have spend the hours and hours to just make sense about semantic that's going on. So you also have to look at the alternatives that we have these days for doing exactly the same jobs, or as you mentioned, also heavily putting a lot of sensors and actually embedding a lot of systems, a lot of sensors and a lot of hardwares in your house. We're just replacing all of them with something that already exists at your place.
Right.
And that is a bigger help, I think, we're trying to do.
Yeah, I think that's a really, really good point. I've talked about on the podcast, I think in the context of, maybe the same kind of thing, presence and possibly home automation, this idea that and actually for many applications, the camera is becoming the universal sensor. And certainly you can do, this stuff with, multiple cameras at least, depending on the number of entrances and exits and rooms you have in your house and all that kind of stuff. But, it's much more invasive, I think, as you're suggesting. And it's much more susceptible to being misused or abused because the raw data itself, is easily interpretable, as opposed to RSSI values and channel noise and stuff like that, you have to run it through some pretty sophisticated algorithms to make sense of. So I definitely get that. And, it makes a lot of sense. And I'm looking forward to kind of keeping an eye on, Aerial and, what you guys are up to.
Yes, we would love to keep you posted keep you posted with the progress of the company and the lines of the different lines of products that we will be launching.
Awesome. Well, thank you.
Thank you very much for having us and giving the opportunity. Thanks.
Thank you, Sam. Thank you very much.
All right, everyone. That's our show for today. Thanks so much for listening and for your continued feedback and support. Remember, for your chance to win in our AI at Home giveaway, head on over to TWiMLAI.com/myai contest for complete details. For more information on Michel, Negar, Aerial, or any of the topics covered in this episode, head on over to TWiMLAI.com/talk/107. Thanks once again to Intel AI for their sponsorship of this series. To learn more about their partnership with Ferrari North America Challenge and the other things they've been up to, visit ai.intel.com. Of course, we'd be delighted to hear from you, either via a comment on the show notes page or via Twitter, directly to me at Sam Charrington or to the show at TWiMLAI. Thanks once again for listening, and catch you next time.